Friends, welcome to this lecture number 5 on chemical bonding and molecular structures. Before going to discuss the topic in this lecture, let us first understand what we have learned in the previous 4 videos. So this is basically a recap of this chemical bonding chapter that we have making lectures, different lectures to make you understand the concept of the chemical bonding. The first lecture we have discussed about the electrovalent bonds. Basically this is a causal theory. Second lecture we have discussed the covalent bond, Lewis-Langmuir theory, and the third lecture we have discussed the Lewis dot structures. How we can able to write the Lewis dot structure much more comfortably. There is basically several steps. If you know these steps, that you can able to understand it. And the fourth lecture we have discussed about the bond parameter. There are some critical bond parameters that we should know. In this lecture we have discussed another very important topic, that is the resonance. Resonance. In this lecture we are going to discuss a very important concept, that is resonance. It is observed for some molecules like ozone, like carbon dioxide, carbonate ions, carbon monoxide molecules. What you observe, that simple one weak structure do not able to explain all of the properties of these molecules. The Lewis structures, it can able to explain majority of the properties, but none of the structure will able to explain the all of the properties of the molecules. As for example, O3 molecule. O3 molecule Lewis structure, we know you can represent in this way. This is the Lewis structure of the O3 molecule. You have to fill, you have to satisfy the octet. This is the Lewis structure of O3 molecules. And another structure you can have, that is, we are just changing the direction of the bond, position of the double bond. The dots is basically the valence electrons. So here you can say octet is this oxygen having the octet, this will be having the octet, this will having the, this octet is folded or not? 6 folded. So these are basically two Lewis structure of the O3 molecules. And from this two Lewis structure, Lewis dot structure, you can able to say, you can able to conclude that O3 molecule is having two different bond lengths. One bond length is double bond and another is your single bond. For the single bond, we know this picometer, its length of this bond is 148 pm, and here there will be length of the bond for the double bond, it will be 128 pm, 121 pm. But when we actually check the bond length of the O3 molecules, the bond length of the oxygen in the O3 molecules, what we find, the bond length is equal. There is no change in the bond length, and the bond length we observe, actual bond length that we observe, it is, actual bond length is 128 picometer. 128 picometer. But from the Lewis structure we get, it will have the two bond lengths, unequal bond lengths, and it is 121 to and 148. but it is not happens actually. And this bond length is in between the double bond and the single bond. So the bond parameters, that is a bond length of this O3 molecule, could not able to explain by the 2 Lewis structure. So it is supposed that molecule must have other structures apart from this, and these structures will be the in between all these Lewis structures, and these structures is called the actual structure which explain the bond length of this O3 molecule. It is called the resonance hybrid, and this has been put in the symbol, and this resonance hybrid structure will be like this. This is the resonance hybrid structure, and these structures are called the resonating structure of canonical structures. Canonical structures, or you can say this is the structure 1 and structure 2 is called the resonating structure. Resonating structures, or you can say canonical structures. This is called resonating structures, and this is called resonance hybrid. This is called resonance hybrid. Resonance hybrid. So this is called resonance hybrid, and these are called the resonating structure, and this resonance has been depicted by this symbol. That is the double-headed arrow. So we can understand the Lewis structures, that neither this Lewis structure nor this Lewis structure you will actually able to explain the bond length of the O3 molecule, actual O3 molecule. So its structure is basically been considered that it will be in between all these structures, and this is called the resonating structure, and it is been displayed like this, and this bond length is 128 pm. This phenomena is called resonance, and it is depicted by these symbols, and this is a resonance hybrid of these two structures, and these two structures is called the contributing structures of canonical structures and resonating structures. We can also say resonating structures. And this phenomena also observed in some other molecules also that we are going to discuss. Here we can this is by these three structures, and all these three structures show a very important thing, that carbon dioxide molecules, the bond length between the carbon and oxygen will be different. It will be triple bond, or it may be single bond, and it may be double bond. Right? Means the bond length is unequal. But when we observe, actually we will find the bond length is 115 pm, and it is same. and it is, you can say, between the double bond and the triple bond. Triple bond length is 110 pm and double bond length is 121 pm. That is exactly between this bond length, actual bond length is same, and exactly in between the triple bond and double bond. That means these Lewis structures could not able to explain the actual bond length, and it will be explained by the resonance hybrid structures, and these structures has been in between all those structures, and they are basically contributing structures, and they are, we can say, resonating structures, or we can say canonical structures. And this is called again a example of the resonance, and in this case majority of the properties of this molecule can be explained by this Lewis structure, but none of this molecule, none of this structure will be able to explain the bond length, and this can be explained by the phenomena of the resonance. Another example we are taking, that is the carbonate ion. We are starting this Lewis structure. Here you can see this is carbonate ion, means we know that is it has a negatively charged ion, and here we also discussed in our previous lectures, in the lecture number, that will be the lecture number 3. In the lecture number 3 we have discussed that how the formal charge can be assessed for the particular atoms in a molecules or ions, and in this case you can see this is a formal charge basically, right? And this is the one of the Lewis structure, and this Lewis structure can be again rewrite in this fashion, that we are this double bond is been changing. 3 Lewis structures you can able to write. This is the 3 resonating structure for the carbonate ions that you can see. The structure 1, structure 2 and structure 3, but none of the structure is able to explain the bond length of the carbon oxygen, because from this Lewis structure you can able to see the carbon oxygen bond length, one either is single or double, that unequal bond length, but actual bond length is equal, and that only can be explained by the resonance. There is a structures in between all these structures. This is called the resonance hybrid structures, and this is going to explain the actual structure of these carbonate ions. So we understand how the resonance is going to enable us to explain the bond length in those molecules. Okay, now we understand how we can write the resonating structures. There are basically several rules that we have to always keep in mind. Rules for writing resonating structure. Resonating structures. First rule, the resonating structure, in resonating structure, the first rule, in resonating structure, the position of the electron shall differs. Means valence electron by which we are able to write the Lewis dot structure, it will differ. But there shall not be any change of the position of the atom. Change of position of the atoms. Relative position of the atom. More importantly, you can say relative position. Relative position of the atom. Relative position of the atom cannot be changed. Each and every resonating structure, the position of the atoms in the molecules will be fixed. Second thing that we always remember in our mind, that is the number of electrons, that is the non-bonded electrons, non-bonded, but we can say lone pair electron shall be same. Lone pair electron shall be same. There will be no change in the lone pair electrons. You can take the example of any of the resonating structure we have discussed, that you will find there will be no change in the number of lone pair electrons. Third thing that is very important, that there shall be no difference in the energy. There shall be no changes in the energy of the resonating structures. No changes means difference will be very, very minute, very less difference. There are no changes, no, you can say less difference. There shall be less difference in energy, in the energy of resonating structures. Resonating structures. Fourth, that is important, that among all those resonating structures, all the structures will not going to contribute similarly towards the stability of the resonance hybrid structures. That structure will be much more give stability, which will have the negative charge reside on the electronegative element, and positive charge reside on the electropositive element, positive element. Okay. So this will have to always, sometimes question arises. You have been given the resonating structures. You have to say which structures is much more contributing, much more helpful for the stability of the resonance hybrid structures. At that time you have to see where the charge has been resided. If it is in the negative charge, in the negative electronegative element, or positive charge in the electropositive, then we will say this will be the much more stabilizing, that is going to stabilize the resonating structure much more, contribution will be there. Okay. So these are basically 4 very important rules that we always keep in mind. And another thing, that the charge that is we are being displayed in the resonating structures, you have to be considered that will be in the corresponding atoms. And another thing, that the compound, the molecules will have the higher number of covalent bonds, which will going to stabilize the resonance hybrid structure much more than others. Okay. Now another thing that we are going to discuss, it is very much important thing, resonance energy. Now we are going to discuss the resonance energy. What is resonance energy? Let us understand. The energy of the resonance hybrid structure is always less than all the contributing resonating structures. And the difference between the resonance hybrid structure, energy of the resonance structures, so we can write resonance energy is basically the difference. It is difference between the energy, difference between the energy of resonating structures, and the resonance hybrid structures. Resonance hybrid structures. This is called the resonance energy. Okay. But there are some misconceptions regarding the resonance, because all those canonical structures never existed for the fraction of the times. Number 1. Number 2, molecules never for a fraction of time exist in those canonical structures, and there is no equilibrium between all those canonical structures. The only structures that is being represented, actual representation of the molecule is the resonance hybrid. Okay, I think that is clearly understood. This concept of resonance, it is basically to explain the bonding length or bond strength, equality of the bond strength of the bond length in those molecules which are not being explained by the Lewis dot structures. Okay, now we make one example to understand which type of questions may come in your exam. This type of question sometimes may come in your exam, that is, which of the resonating structure is not a correct. For this you have to see always, in this case, what will be the answer? The answer in this case will be this. Because in this case you can see here oxygen atoms is being displayed with the 10 numbers of electrons, 6 and 10s. But 10 number of electrons is not possible because oxygen do not have d orbital, that it cannot able to expand its valence. towards, because it do not have d electrons, so how can it expand its, how can it is able to accommodate more than 8 electrons? That is not possible for these atoms. So these structures is not possible, because you can see here total 10 electrons has been surrounded by the oxygen atom. In any other case, this type of things is not going to happen here, you can observe. So this will be the answer. Okay, that is all for today's lecture. In this lecture, we have discussed a very important concept, that is the resonance, and we have also learned how can we able to write the resonating structures very minutely, and what is resonance energy, and some examples we have discussed. Thank you very much for watching, and the next lecture we will going to discuss another very important topic in this chapter. Thank you very much.